Okay, sections 8.1 and 8.2 are about hypothesis testing. HO is called the null hypothesis. HA is called the alternate hypothesis. The rule for what goes in HO and HA, if it is a claim and says equal, then the claim goes in HO and HA will be not equal. If the claim is more, less, or different, the claim goes in HA. HO will be equal. Okay, another thing I forgot to put, another symbol for this is H1. Okay, HA and H1 are the same thing. Okay, HO always contains the equal. HA can only be less, more, or not equal. HO and HA always have the same number in them. Okay, the parameters, P is a proportion, mu is mean, and sigma is a standard deviation. Okay, let's talk about some examples. Okay, we're using sample data. That means we only have part of the data. We cannot 100% say something is true unless we have all of the data. Okay, we just have enough evidence to support. We can never prove if we don't have all the data. So let's say I survey 1,000 college students, ask them what type of device they use. I find 68% use a MacBook. This does not mean 68% of all college students use a MacBook, okay, because that's just 68% of the 1,000 sampled. Okay, since we have sample data, instead of all the numbers, we cannot be sure. We're making a guess. When making a guess, we could be wrong. This leads to possible error. Before we talk about error in statistics, we will use an analogy of the American court system. When somebody is on trial, the jury is instructed to believe the person's innocent until proven guilty, until they're given enough evidence to go against the presumption of innocence. So the null hypothesis in court, somebody is innocent. That's what you're supposed to believe until you've given evidence to make you go against that. The alternate hypothesis is the person is guilty. There's a trial. The jury makes a decision. Since they were not at the scene, they cannot be 100% certain. There are two bad things that could happen. An innocent person might go to jail. A guilty person might go free. Now let's correlate those to statistical testing. A null hypothesis is the person's innocent. Type 1 error is the error of rejecting a true null hypothesis. In the court system, this would be rejecting that the person is innocent. If the null was really true, but they rejected it, that means they're really innocent, but the verdict is to reject that they're innocent, so the verdict is guilty. But the null was actually true. This is a bad thing of sending a truly innocent person to jail. That's why it is an error. Okay, let's go back. The null hypothesis, the person is innocent. Type 2 error is failing to reject a false null hypothesis. In the court system, this would be not rejecting that the person is innocent. This is the verdict of not guilty. They don't reject that they're innocent, means they just keep believing that. Okay? But if the null was false, this means the person was really guilty. This is the bad thing of letting a guilty person go free. That's why it is an error. Okay? So let's identify some errors. Identify type 1 and type 2 errors. Let's say there's a claim the proportion of people that write with their left hand is equal to 0.29. Since the claim said equal, we will use HO, P equals 0.29, and HA, P is not equal to 0.29. Type 1 error, reject a true HO. I reject that the true proportion is 0.29, but it really is 0.29. I reject HO, means I reject that it's 0.29, but 0.29 was really true. Type 2 error is fail to reject a false HO. I don't reject HO that the proportion is 0.29. Mean I keep believing it's 0.29, but that's false. I don't reject that it's 0.29, but that is false. It's really different from 0.29. The significance level is the error that will be allowed. We have error because we have a sample data, we only have part. There's no way to be 100% accurate if we do not have all the data. The significance level that we will use, we're going to use 0.10, which is 10% or less. Okay, we can use 0.10 or anything less than that. The problems will tell you what level to use. The Greek letter alpha is used for significance level. Okay, the p-value is a probability that represents the chance that HO is true with this sample data. So how do we decide if we believe HO or HA? Okay, and remember, HA is the same thing as H1. Okay, these are the same thing. Possible decision number 1, if the p-value is less than the significance level, reject HO. There's enough evidence to support HA. Believe what is in HA. Okay, HA is the alternate. Possible decision 2, if the p-value is more than the significance level alpha, fail to reject. There is not enough evidence to support what is in HA. Okay, now we don't say accept HO because it's the null hypothesis, which means you're believing it from the beginning, just like you're supposed to believe somebody is innocent from the beginning. Okay, all right, so in our homework, a null hypothesis, HO, is a working hypothesis to make a claim. An alternate, H1, is the opposite of HO. Type 1 error, reject a true HO. Type 2 error, fail to reject a false HO. Okay, significance level is the probability of making type 1, and the probability of making type 2 is beta. Okay. The significance level probability of making type 1 error, okay, we also call that alpha. Okay, Greek letters can be inserted by using the insert advanced symbol. Okay. The alternative hypothesis determines the tail. Okay, the tail is represented by the probability. Okay, we never prove a hypothesis because we're using sample data. That means we don't have all. Okay, if I survey 19,034 students, I can't prove anything because I haven't asked all students. The only thing I know about is that 19,000. Okay. The null hypothesis always has the equal. The alternate hypothesis is what the claim is. Okay, examples of claims. A claim is made that an average is more than 80. Okay, so since we have more, that goes in H1, the alternate. So it's average, which means the mean, so we use mu. So that means mu is greater than 80 is H1. Okay, HO always has equal. When H1 is greater than, it's called right-tailed. Okay, number 2, claim the pulse rate is less than 69.2 beats per minute. Okay, given a random sample, you're given a mean and a standard deviation. Okay, the claim said less than 69.2. Okay, so since it has less than, we're going to use H1 that it's less than 69.2. Okay, HO is always equal. We're using mu because it said mean. Since H1 has less than, this is called left-tailed. Number 3, the mean is 69.2. Find HO and HA. Okay, our claim is that it is. That means equal. Okay, if the claim is equal, it goes in HO because HO always has equal. Okay, so when HO is equal and that's your claim, the opposite is not equal. Okay, you only use greater or less if it says more or less. Okay, when we have not equal in H1, that's called two-tailed. It's also called both-tailed. Okay, all right, examples of a test with calculations, the whole thing. The claim, mean is less than 20, use significance alpha of 0.05. So HO, mu equals 20, H1 mu is less than 20. And we're given sample statistics of X bar is 18.5. Our sample standard deviation is 2.6. Okay, remember X bar is the sample mean. Sample means we don't have all the data, we just know some of the data. Okay, and we're testing that the claim is less than 20. Okay, since the claim is less, that goes in H1. HO always has equal. Okay, we're using a one sample t distribution since the population standard deviation is not known. Okay, it's one sample because we're not comparing two groups. All right, so use SALT to find the calculations. Okay, it'll pull up use SALT anytime you can. On number 7, it doesn't have the SALT link on there, but you can use the SALT link for this one right here. Okay, and it pulls up one sample T. The sample mean was 18.5. Sample standard deviation was 2.6. Okay, and I did not write down the sample size in this problem. Okay, let's just look at the WebAssign questions. Okay, so this said 51. The questions are randomized, meaning the numbers change, okay? I'll just open it back up. Okay, sample mean 18.5. Sample standard deviation 2.6. Sample size, let's just say 51. Okay, we're doing a hypothesis test. What are we testing? We're testing that it's less than 20, so you put 20 here. And we're going to change this to less than. Okay, hypothesis mean is 20, and our alternate is less than. Okay, generate results. Okay, the two things that you need, the test statistic and the p-value. Okay, so let's go back to our p-value, and let me type in about use sample size equal to 51. Okay, did you see how small that was? 0.000. Okay, so that is less than 0.05. Okay, so the decision will be one of two things. Which one will it be? It'll be this one. Okay, the p-value of 0.000 something was less than 0.05. Okay, this is alpha. Okay, it's less than 0.05. We're going to reject HO. There is enough evidence to support that the mean is less than 20. Okay, if it was bigger, you would use the other decision. Okay, example 2, test that the claim that the mean is less than 8. So that would go in the less than. Okay. I'll just make up a sample size of 45. Okay, this time it says significance level is 0.01. Okay, and remember that is alpha. Okay, that's the Greek letter alpha. Okay, so we would do the same thing there. The same exact one. Click on salt and put in our values. Sample means the X bar. Sample standard deviation is the S. And put in your sample size. Okay, and make sure you have equal to 8 and less than 8. Okay, when you look for that p-value, what you're comparing it to is alpha. Alpha is the significance level. Significance level is this Greek letter alpha, and it is given to you. Okay, so that's what you compare your p-value to. You only have one of these two things exactly like that. There's no other wording that it would be. You either reject there is enough evidence to support what is in H1. Okay. You fail to reject there is not enough to support what is in H1. Okay. That the mean is less than 20. Okay, these are wrong. Okay, I must have copied and pasted. Less than 8 or less than 8. Okay. I copied and pasted it from the previous example. So the decision, p-value less than alpha, reject, enough evidence to support what's in H1. Fail to reject, not enough evidence to support what is in H1. Okay, you're always deciding if the claim has enough evidence. Okay, and that is our video for these sections.